Hey everybody, this is the 2017 AP Free Response question number 5. So we've got two particles moving along the x-axis on the interval 0 to 8. The position of particle P is given by this equation right here. The velocity of particle Q is given by this equation, and particle Q is at position x equals 5 at time t equals 0. So they give us the initial position for particle Q. In part A, they're asking for when particle P is moving to the left. So we know that if we're going to be looking for when a particle is moving to the left, we're looking for when the velocity is less than or equal to 0. So we're going to need to find the velocity function and then do a sign analysis to figure out when it's negative. So let's see, we need to take then the derivative of the position function. So we're going to need to remember some of our derivative rules here because this is a natural log. So the derivative is going to be 1 over the inside, which is t squared minus 2t plus 10, times the derivative of the inside, because that's that chain rule, so 2t minus 2. And so this really is just 2t minus 2 all over t squared minus 2t plus 10. Now that we have the derivative of the position, so we have the velocity function, we need to find the critical points. So we're going to set the top equal to 0, and we're going to set the bottom equal to 0, because that'll tell us when the derivative is equal to 0 or undefined. So here we end up getting t is equal to 1, so that's a critical point, which is good. And then for this second piece here, for the denominator, we would try to factor it first. But when we look at that, we can't factor it. So if we were to try and maybe do some quadratic formula, we would have 2 plus or minus the square root of negative 2 squared minus 4 times 1 times 10 all over 2 times 1. And really, we're going to end up getting on the inside here a negative number, right? Because we'd have what, 4 minus 40, so we're going to have negative 36. And so I'm not even going to keep going with that because that's going to give me imaginary answers there, which means I don't need to keep going because I'm not going to have any critical values then. So although I wanted the work there to show it to you, I'm going to kind of just cross it off then because it's not going to matter. Okay. So now we have our critical point here. At t equals 1. So now we can do our sign analysis. So the velocity of particle P, let's see, we know we're starting the interval at 0. We have a critical point at 1, and this ends at 8. So if I want to pick a point between 0 and 1 and plug it in to figure out the sign, I'm going to be plugging into my velocity function right here. So if I plug in, let's say 1/2, on the top I would get a negative, on the bottom I would get a positive. So overall then I would have a negative answer. And then let's say I plug in, I don't know, t equals 4. I would have a positive over a positive, so that would end up being positive there. And the place that I care about then is where it's negative because I'm looking for where the particle is moving to the left. So it's going to be from 0 to 1. So we can say particle P is moving to the left. On the interval from 0 to 1 because the velocity of particle P, which is the derivative of the position, is less than or equal to 0 on this interval. So there we go. There's part A. So this was worth 2 points. It was a point for getting your derivative, and then it was a point for writing your interval here. And I guess technically you didn't need to explain it, but it's always better to explain it than to not. So 2 points, one for finding VP of t, and then one for your interval. All right, for part B, then, we are asked to find the times when the particles are traveling the same direction. So we already did this sign analysis for particle P. Now we need to do it for particle Q. So let's see, we're told that VQ of T is equal to T squared minus 8T plus 5 plus 15. All right, so we want to know when is that equal to 0. So we can go ahead and factor. We would have T minus 3, T minus 5 equals 0. So we would have critical points at 3 and 5. So what we're going to do is we're going to make a double sign chart now because we've got the velocity for P and we've got the velocity for Q. So VP of T, and then we're going to do VQ of T. And we know both of them are starting at 0. We know P has a critical point at 1. We know that Q has critical points at 3 and 5, and then they're both going to end at 8. So I like to kind of just draw some dotted lines for the ones that don't actually match for the correct function, if that makes sense. So 1, 3, and 5. So we already know for particle P that from 0 to 1, the velocity is negative, and from 1 to 8, everything is positive. So we can just put some positive signs here. All right, and then what we need to do is we need to do the sign analysis for particle Q. So if we think about a number between 0 and 3, let's say 2, if we were to pick 2 and plug it into the velocity function here, we would have a negative times a negative, so it would be positive. So both of these here are going to be positive because that's all the same interval. It's from 0 to 3. Then if we were to plug in something between 3 and 5, so I don't know, let's plug in 4, we would have a positive times a negative, so that would be negative. And then plug in something between 5 and 8, let's say maybe 6, we would have positive, positive. So this question is asking us where the particles are traveling the same direction, or when the particles are traveling the same direction. So we need them to have the same sign on the velocity. So that would be between 1 and 3, and it would be between 5 and 8. So the particles travel the same direction. On, let's see, 1 to 3 and 5 to 8, because VP of t, which we know is xp prime of t, and VQ of t are the same sign on these intervals. Again, I guess it doesn't necessarily ask for an explanation, but it's always a good idea to have your explanation here. Although actually, they really do want it, so yeah, have it there. In terms of points, this was also worth 2 points. So it was 1 point for your interval, and or for both intervals, and then it was 1 point for the analysis. And just as a quick side note, what they did do is they said you would get 1 out of 2 if you only have one interval. and you would get an automatic 0 out of 2 if you have no analysis to go with it. So, and really, they're looking at that table as the analysis, but you want to have your justification in your answer also. Okay, in part C here, find the acceleration of particle q at time 2, and then is the speed of particle q increasing, decreasing, or neither? So to find the acceleration of q, so we're going to need the acceleration of particle q at 2. We know that that means take the velocity and take the derivative at 2. So let's actually find the derivative of the velocity function so we can get the acceleration. So AQ of t is going to equal 2t minus 8. And so if we plug 2 in there, we would get 2 times 2 is 4. Minus 8 would give us negative 4. And then in order to determine whether the speed of the particle is increasing, decreasing, or neither, we need to look at the sign on the acceleration and the sign on the velocity function. So let's actually go ahead and do that then. Let's find the velocity at 2. So let's see, 2 squared minus 8 times 2 plus 15. So we would get 3. Yeah, 3. So if we look then, we can see that the acceleration at 2 is negative 4, the velocity at 2 is positive 3, so the speed of the particle must be decreasing. Decreasing at t equals 2 because the acceleration at 2, which is the derivative of the velocity at 2, and the velocity at 2 are opposite signs. All right, for this question, this was worth 2 points. So it was 1 point for actually finding the acceleration at negative 4, and then it was 1 point for your answer with your reason. And last but not least, here in part D, we're asked to find the position of Q the first time it changes direction. Well, we know that Q changes direction when the velocity changes signs. So I'm not going to rewrite everything. I'm just going to go back up to my sign chart up here, and I can see that the first time that velocity changes, um, the first time that the velocity of q changes is right here at t equals 3. So I'm going to go back down to part D here then. And I know that the first time it changes sign is at t equals 3. So I need to find the position of particle q at 3. Well, in order to do that, I need to use the initial condition that they gave me, which is x equals 5 at t equals 0. So I'm going to do xq of 0 plus the integral then from 0 to 3 of my velocity function. All right, so remember, position is the initial plus the integral of velocity. So we were given 5 plus the integral from 0 to 3 of t squared minus, was it 8t plus 15 dt. And so let's see, we have 5 plus, and we're going to need to take an antiderivative here. So this is 1/3 t cubed minus 4t squared plus 15t. And we're going to evaluate from 0 to 3. Well, we know that really when we evaluate it at 0, we're going to be subtracting off all the zeros and subtracting off a c. So really we can just plug in the 3. So we get 5 plus, We have a third times 27, which is 9, minus 4 times 9, which is 36, plus 15 times 3, which is 45. And so we get that the position of particle Q at 3 is equal to, if we simplify all that out, we get 23. All right, and this question was worth 3 points total. So it was 1 point for using the initial. It was 1 point for your antiderivative, and then 1 point for your answer. All right, thanks for watching.